Okay, we're Team Energy. I'm Gian Calzado.
I'm Jose Rivera.
I'm David Piedra.
And I'm Penelope Torres. The goal of this project is to utilize sensors and the Arduino platform to build systems for testing distance, water depth, and temperature. The requirements for the temperature measurement system include a range of 0 to 100 degrees Celsius, a resolution of 0.5 degrees Celsius or less, and an LCD digital display. The requirements for a contactless distance measurement system is a medium of measurement, which is air, the range of 5 to 50 centimeters, and a dial style using a servo motor. The water depth system needs a range of 5 to 40 millimeters and a dial display using a servo motor. Along with this, we have to make sure that we calibrate the systems for accurate measurements.
So to meet the required test and analysis, we followed lesson 11, 13, 14, and 21 that were provided. We also calibrated the temperature measurement system, the contactless distance measurement sensor, the calibration of the water depth, and then we assessed our results.
So following the instructions provided, here's the circuit diagram how we make the connections. As you can see, the positive cable, which is the red one, is connected to 5 volts. Then the black cable, which is the negative port, is connected to the ground, and the pulsation is connected to the D9 on the motherboard. And here you can see how it's actually connected in that person, and then we use this USB cable to send the signal to the computer. And then this is a code that we provided that will make the motor oscillate 180 degrees. Now I'll actually run it, and you will see how it works. Now to stop it, we only have to create a new script, and since the loop doesn't have anything on it, it will just stop when we click run. You see.
Some of the problems we encountered was to fix all the connection issues so that we could obtain the signal from the Arduino board. We fixed this issue by going to the menu, choosing tools, then port, then selecting the Arduino board available. Due to the simplicity, the calibration was not required because the motor can oscillate only at 180 degrees at a time. Nevertheless, the axis of rotation was not symmetrical to the shape of the servo motor, making our initial zero skew.
Following the instructions of lecture 21, a circuit capable of measuring room temperature was built. Now on screen, you can see the digital circuit showing all the connections that were made, and here is the actual physical circuit connected to the computer to the USB cable. Now, using the code provided, we made the circuit read the room temperature. As you can see
The
here.
problem we ran into was that the 10K ohm resistor wasn't connecting properly to the board and not giving us. The way we fixed the problem was we basically moved the resistor different times, different ways, so that we would have a correct connection onto the board and it could display the
For the
temperature.
measurement system, we made sure that we followed lesson 13 for the water level sensor and lesson 11 for the servo motor. And we made sure that everything was connected properly. We had to adjust certain cables so that everything connected properly. And then we opened up the code, which we had to modify so it includes also lesson 11. And dip the sensor into the water. You can see that in the serial monitor that a level of ADC shows up. The problem we ran into was that the code wasn't outputting any value, so we had to change the baud. We troubleshooted and chose the 96,000. We also had trouble connecting certain cables so that both the servo motor and the water sensor would work together. Electronic sensor setup, we made sure that we followed lesson 14 and lesson 11 provided and made sure that everything was working correctly. We had to change several cables so that they would work correctly. When we run the code, you can see in the output that it shows in centimeters the distance that the ultrasonic sensor is taking as you move an output. What we ran into was connecting both the servo motor and the ultrasonic sensor. We also had to implement their codes together, as you can see here. And we also had an error when it comes to the output. It was showing question marks, so we had to change the baud. We troubleshooted and found our answer. For calibration of the thermistor, we're going to measure temperature in three different times with the thermistor and a thermometer. We're going to first use an ice cube and put it on the thermistor and also on the thermometer. We're going to use also room temperature and we're going to use hot water. For calibration, we marked up certain millimeters from 5 to 40 millimeters, and we are going to dip the sensor into the cup and pour a certain millimeter quantity of water and compare the values of the output and the millimeters. For calibrating, we set the 0 centimeters to the ultrasonic sensor start, and then we move an object and we place it in a certain distance, and we compare the distance that the ultrasonic sensor outputs and the one in the room.
The significance of the servo motor experiment was to understand and ease their way into the setting up and management of the Arduino code and hardware. In addition, it shows how the pulse caused by the Uno R3 alters and affects the direction of the motor. The temperature measurement system allows to create a more robust and complicated setup. In comparison with the rest, this is the most complicated one, getting closer to ones that will be used in the field. This specific one allows to design a temperature-sensitive system that can be designed to record any changes in temperature. This can be implemented in all kinds of areas in aerospace and mechanical engineering due to the impact of temperature in structures and designs.
The significance of this experiment was to learn how to include a new library to an already provided Arduino code in order to make a motion sensor functional. Several data points for distance were obtained using the ultrasonic sensor provided, and a plot of distance versus time was made. One scenario in the engineering world where the skills and concepts learned to carry out this task might be used is in the jet aircraft industry. The implementation of ultrasonic motion sensors are a key and essential condition when designing, building, and testing this type of aircraft. The significance of this experiment was to implement an Arduino code and a water level detection sensor in order to measure different levels of water depth of a container with a fixed volume. Calibrations were made using a ruler, and uncertainty and discrepancies in the values obtained were analyzed. A scenario in the engineering world where a similar task might be performed is in the construction of naval ships. When designing a ship and taking into account buoyancy force, measurements for the water depth are necessary to decide the portion of the ship that must be submerged.